velocity is v, acceleration a.
And I think we did this on the first day. There's sort of deja vu to it.
I think we did. Yeah, we did.
Okay.
We did force, position, displacement, velocity, and acceleration for vectors, and we had our scalars.
Yeah. Now there are scalar analogs of it. From displacement, there's distance. These are scalars. Velocity, the analog is speed. So if you see these words, these are scalars. Direction doesn't matter. And acceleration, unfortunately, is called acceleration. And the symbol is just basically the same as we used over there, except without the vector symbol. So A, V, and delta X, R, whatever. All right, so position. I'm going to put it right here, and then I'll eventually erase that. Position is where an object is with respect to the origin. You establish some place as 0, and then you can talk about it from there. So if we consider, we're going to simplify it, Columbia, South Carolina as the origin, my position right now would be 200 miles north. Charlotte's the origin, we're 100 miles north. I need the north because it is a vector and their direction matters. So I'm going to establish 0 right there. And I'm going to move back and forth. We need to establish a positive direction, so I'm just going to say to the right is positive. I could make to the left positive. There's a positive direction. So right now, if this is a one-dimensional problem, my position is positive, negative, or 0. Am I on the plus side of 0, the negative side of 0, or am I at 0?
You're on the plus side of 0.
So my position is
Positive?
positive. And this is the way the game is played. What about now?
Positive, but more positive?
Yeah, just positive is fine.
Okay.
In unison, everyone can play. What about now?
Positive.
All right, we got 2 voices. What about now? It depends on,
Yeah.
the intent is I'm at 0.
Oh, okay, yeah, 0.
Good. And now?
Negative.
All right, we're on a roll. Displacement. Where an object is with respect to the starting point.
What's the difference between the starting point and the origin?
If we take longitude and latitude as sort of a set system.
Sure.
So 0, 0 is somewhere in North Africa, I believe.
Yeah. Mm-hmm.
My displacement, my position is, well, I'd give you longitude and latitude.
Yeah.
But my displacement, I was born in Florida, so my displacement is primarily north, not a lot of east and west. So it's just where am I relative to my personal starting point in that example. All right, let's do another example.
Okay.
Let's say this is my starting point, right here. I'm at my starting point. My position, positive, negative, or 0?
Positive.
It's positive. I'm on the plus side of 0. My displacement, where am I relative to the starting point?
You haven't moved.
So,
Your displacement 0.
0, yeah. So I have positive position, I have 0 displacement. I haven't gone anywhere.
Oh, okay, okay. Thank you.
My displacement now,
Positive.
position, my position,
Positive.
displacement,
Negative.
Position,
Negative.
displacement.
Negative.
Now, there are actually two types of displacement. There's overall displacement. And then there's instantaneous displacement. And the difference is, as I'm walking back and forth here, my overall displacement depends upon where I am relative to that starting point right there. That's overall. My instantaneous is where am I relative to where I just was. So as I'm walking this way, my displacement, my instantaneous displacement is positive because I was just there. So in that moment, I started there and now I'm here. Overall displacement, well, I'm still on the negative side of where I started. And the reason I bring this up is that this is the default. If I just say displacement, this is the one I mean. So this is default. If I want you to tell me about the instantaneous displacement, I need to specify instantaneous. So as we're doing this exercise here of plus minus 0, displacement is, when I say ask about displacement, I'm talking about the overall displacement. Where am I relative to the starting point?
Can you just repeat that difference one more time between overall and instantaneous?
Who doesn't love graph? I got a graph here. You can picture this. I got a flat map and I've drawn a grid on it, and I'm starting here. That's my starting point. And then I go to here. This is my initial position right here, where I am relative to the origin. That's my final position there. So my displacement is where I am relative to this part. So my displacement is there.
Okay.
So, was that the part that you wanted, or were you talking instantaneous or overall?
I wanted to know the difference between instantaneous and overall displacement.
Okay, so if I'm looking at my overall displacement for my life, I got Florida, and now I'm here. My overall displacement is, we'll just say 400 miles north. However, if I'm concerned about getting home, I need to sort of lower that scope. I don't want to look back almost 60 years to where it was.
Yeah.
So instantaneous displacement is you're narrowing that scope of the starting point. It happened a moment ago. So I'm now walking in this direction. A moment ago I was here, and now I'm here. So my displacement is that way.
Okay.
That's my instantaneous displacement is that way. My overall displacement still depends on what I consider my starting point.
So like applicable to physics problems, like not like considering like your like personal displacement from Florida, what would be an example of overall displacement? You said that's gonna be the default, right?
Yeah, example of overall displacement. If I want to figure out what my average velocity is displacement divided by time. That's the math equation. Whatever my displacement is, divided by time. Average. So, if we go back to my birth, that's my starting, well, now let's take something simple. We'll take home. Home to here. So if I consider home to be my starting point for the day, then my average velocity would be 5 miles over 6 hours, how long ago I left. So my average velocity for the day so far is, well, there's the math part, 5/6 miles per hour.
Okay.
My instantaneous displacement, or instantaneous velocity, is the instantaneous displacement divided by time. The magnitude of that, that's what your speedometer shows.
Okay.
Yeah. Average velocity, it's not telling you, although from a physics point of view, it would be interesting if cars did that, but they don't. They give you instantaneous values.
Okay. So like just to keep going, what would the math like for that look like for your personal example from here to home?
Instantaneous velocity, I'd have to pick out a specific point in time. I'm not looking at
Let's say,
overall,
like-
I'm looking at, so right now,
Yeah.
it's 0,
Okay.
because I'm not moving.
Okay.
Good to go?
Yeah, thank you.
Other questions? All right, so velocity, you sort of look at it in two ways. One is the math way right there, it's the displacement divided by time. And it's how fast an object is moving and in what direction. If I just did how fast an object's moving, that's the speed. I need the direction to make it velocity, which is a vector. Again, there are two types. There is average and instantaneous. Default is instantaneous. So when we do this plus minus 0 thing, then instantaneous velocity is what I'm going to be asking for. I'll just say velocity. If I want you to tell me average velocity, I will specify the word average. So what is my velocity right now? Positive, negative, 0.
Negative. Oh wait, no, sorry, never mind. I was looking at the 0 on the board.
0.
Yeah, 0. Again, assuming that's 0 and that's the starting point, those haven't changed. What about my average velocity?
Zero.
No, not 0. Am I at my starting point? Looking at this formula right here, the average velocity is displacement over time. My displacement, positive, negative, or 0?
Negative.
Negative. So my average velocity is negative. Now, we can't actually do the calculation without time there, but I'm on the negative side of where I started. My average is negative. On that vein, or in that vein, something with a vein, I'm racing Usain Bolt. We start here, we take off, we run around. 400 meters. Usain Bolt does it in 30 seconds. Let's make the math easier, we'll just say 40 seconds. That is, wait, 10 seconds for 100 meters, so yeah, that's ballpark. So this is Usain Bolt's time. And I do it in 240 seconds. Which one of us has a greater average velocity?
Usain Bolt,
How'd you get that?
because the distance is the same, but the time is less for him. Or the displacement is the same.
The displacement between us is the same. What is the displacement?
400 meters.
Ooh, no. That's the distance.
The displacement is 0.
Yes, we ended up back where we started. The displacement is 0. What is his average velocity then?
Is it 0?
And what is my average velocity?
0?
I am as fast as Usain Bolt. Let's take it one step further. He finishes the race and I'm still about here. Who has a greater magnitude of average velocity now?
Do you, because you have a greater displacement? So you're faster
He
than
is,
Usain
in
Bolt.
40 seconds, he is back where he started. He has gone nowhere in 40 seconds. Whereas after 40 seconds, I've gone somewhere. My average velocity is a greater magnitude than his average velocity. I am faster than Usain Bolt. Obviously, I'm ignoring speed. If we're talking about speed, then you were right on. He went 400 meters in 40 seconds. His average speed was 10 meters a second. My average speed was somewhere between 1 and 2 meters a second.
So it would like change if you were racing him like 400 meters straight?
Oh yeah, that's why I don't do that example. And as far as direction, if I just said what's the average velocity, and I didn't say magnitude of, well, his would still be 0 with a vector symbol over it, but that would be the direction, whatever that is.
So for average velocity, it's displacement over time?
Yes.
And then for instantaneous velocity, it's?
Sort of instantaneous displacement.
Okay.
So my instantaneous velocity right now, or as I will just say, my velocity, positive, negative, or 0.
Velocity?
Yes. So an answer, let's go the other direction. My velocity?
Positive?
Yes. Because velocity, default, instantaneous, it's where I am relative to where I just was. I was just there. I've now moved in the positive direction. My velocity now? Yep, negative. It's the direction of movement. I'm moving in the negative direction. Because that's positive, so that has to be negative. All right, here we go. Rapid fire. Again, starting point, 0. My displacement,
Is positive?
position,
Positive?
velocity. My velocity, my position,
Positive?
my displacement, position,
Negative?
velocity.
Negative. Positive?
I should
You
have timed that
switched it
better.
up.
And my displacement.
Positive.
All right. We're cooking. Got just a couple minutes left. Acceleration. It's the hard one. Well, we can do it in 4 minutes. Acceleration is the change in velocity over the change in time. That would be average acceleration. We'll deal a lot with constant acceleration, so. But instantaneous versus average are the two types. Instantaneous, which is the default, and then there's average.
You're using overall and average interchangeably, right?
In some sense, yes, but in my mind, there is a difference, but
Yeah, we can move there for now, for the sake of time.
another way of looking at acceleration is not just the change in velocity, but the force. I know that acceleration is also the total force divided by mass. What I would like, this would be my dream here, is that if anyone thinks negative acceleration means you're slowing down, cast that from your mind. Negative acceleration by itself, if I tell you acceleration is negative 3 meters per second squared, you have no idea without more information if that's speeding up or slowing down. Let's think about it in terms of force, acceleration and the net force. If I'm walking in this direction, my velocity is
Negative?
negative. If I am pushed in the direction I am moving, will I speed up or slow down? And my acceleration would be,
More negative.
it would also be negative, because the force is in the negative direction. So the acceleration is negative. My velocity was negative, my acceleration was negative, I speed up. And that actually works. If acceleration and velocity are the same sign, you're speeding up. You're becoming more positive or more negative. If I am turning around, I walk in the negative direction. At that moment I turn around. At the moment I turn around, what's my velocity?
Zeros?
Yep, I think that's what you were saying. And my acceleration at that moment I'm turning around,
Also zero?
I got a 0 and a positive.
Positive.
Why positive? In terms of forces, what forces are being applied to me at that moment I'm turning around? Yeah, if that were slippery, which way would my foot go? And therefore, the way the friction is acting on me,
Add another way.
positive direction.
Okay.
If acceleration is zero and the velocity is zero, and that is a common mistake, another thing, cast from your head. If acceleration is change in velocity over change in time, and your velocity is zero, if acceleration is also zero, that means your velocity doesn't change, which means you don't move. It is possible to have zero velocity and acceleration not be zero. Every time you're at a stoplight and you are stopped and then you start to move, that's an example. There's an instant there where you're not moving, but your acceleration is positive. That's how, or acceleration is not zero. And that's how you actually start to move. And on that note, we'll end it there. Thank you for your patience. I know this was potentially a long, grueling session. The lab we'll do on Monday will relate to this. And what I traditionally, it takes 2 lab periods to do it.
This is how you
But
do
you have to play with the lab question. Excuse me? Yeah.
I didn't stick with the graph too.
Is your name on it? Yeah, let's get your name.
Is there a stapler in there?
Yes, under my
Can I grab it?
binder.